Hey, this is Mr. Morrison, and today we're going to talk about symmetry, just like this butterfly silhouette has. I recently saw an ad for a movie. It's March. I didn't see the movie. I just saw the ad, but they were using symmetry in the movie. So the Time magazine's face and this guy's face almost looked identical on both sides of it. So he put up to there, kind of making a line of symmetry with the magazine. It's not perfect line of symmetry. It's not the same person, but you can tell that it looks very close to being identical to each other. Back to the butterfly. So to prove it has line symmetry, if you take the little butterfly and cut it in half, and it looks the same on both sides, then it would have line symmetry. The line is the actual line of symmetry, and we would say it has line symmetry. And you notice I made a dotted line. It should be over a little bit. I'm a little bit off, but it needs to be dotted so you don't assume that it's part of the shape. Like this is another good example of a real butterfly, but this line should be dotted so you don't think the line is part of the butterfly. So line symmetry is when you can cut something and it looks the same on both sides. Similar to that is rotational symmetry, and that's if you take a shape and can turn it and it looks the same. So this shape looks the same here as it does here. So you can spin it 1, 2, and then back to 3. So if we want to figure out how many degrees it was, we would just take the amount of times that you can spin it and divide it by a full spin, which is 360. So 360 divided by 3, because it looks the same at three different times. 1, 2, 3, and then back to the original 1. So every 120 degrees it looks the same. So it has rotational symmetry every 120 degrees. The star has both. It has line symmetry and rotational symmetry. So rotational symmetry, it would have it at 1, 2, 3, 4, 5, and then back to where we started. So it would have it at each point. So it'd have it 5 different times. So if you took 360 divided by 5, that would show you how many times it has symmetry at every 72 degrees. It also, if we took a line and drew it on there, it has it down the center. It looks the same on both. And then you could go through the other peaks too. If you went through here, that would work. Went through here, that would work. And this last one, cutting it down there, so there's 1 line, 2 lines, 3 lines, 4 lines, and I missed one, so it has one like at every peak. This would have line symmetry 5 different times. You cut it 5 different ways and it looks the same. You might also be asked to complete something that has line symmetry. So if this red line is a line of symmetry, to draw the other half of it, you're going to see my artistic abilities in full action here. You'd have to just draw, kind of mirror the other shape where it goes. And I'm hoping that you can do a better job at this than I can. I got started over. That was bad, even by my standards. So it goes out, then back in, then back up this way, down to here, back out, and then back in. A little better. Not too great though. It might be easier if I had the grid paper on, but you get the idea of what it hopefully should look like, and I'm hoping you do a better job than me. The last one is rotational symmetry that might ask you to complete. So if you had this figure and had to complete the rest of the figure using rotational symmetry to make it fourfold, you would just take this and mimic it till you got something that turned 4 times and looked the same. So this would be one of the 2 folds, and I'm going to do it in different colors just so you can see each one. The other one would go up to here, and then the last one will go there. Then when you spun it, it would have rotational symmetry those 4 different times to make it fourfold. So those are the different kinds of symmetry: rotational and line, which hopefully you're a better drawer than I am. Please answer the questions at the right. Good luck.